Hey everyone, and welcome to the 12th lab of the Introduction to Malware Binary Triage course. Today we will be performing network monitoring of multiple malware variants. So first and foremost, like every other lab, get your lab manual open. It will look something like this. And as we've mentioned in every other lab, this will provide all of the steps that we will be conducting throughout this lab. However, we will also be conducting each step within this video. We will also be using two separate virtual machines. The first is our Remnux machine, and the second is our Microsoft Windows machine here. So the next thing that we're going to do is switch back to our Remnux machine, and we're going to open Wireshark. So I'm going to type Wireshark, and then I'm going to provide an ampersand, and this is so the process will run in the background once we've executed this command. Okay. And now we have Wireshark open here. So some of these buttons are a little bit different than others. This is just because they have different resolutions, and I was trying to make this resolution as big as possible. So we'll do our best to deal with that, but just so you know, that's why some of these buttons look a little wonky. So the first thing that we're gonna do here is click on this capture options button up here, and we're gonna select an interface to listen on for network traffic. So helpfully we're seeing some network traffic in this little diagram here in this traffic tab. So we know that there is traffic being received on that interface, and we can even select any for all interfaces. But for the sake of simplicity for this lab, we will be selecting ENS33, which is our Ethernet interface. That is listening on our host-only virtual network. So I'm going to select that line and click Start. And we start seeing network traffic right away. If we want to check our network connectivity between our hosts, we can go back here, and I'm going to type in cmd.exe, and I'm just going to do ping 8.8.8.8, and we're receiving responses back from our Remnux machine. And if we go back to our Remnux machine here, we can see we have a number of ICMP echo requests that were received, and then those ICMP echo requests were replied to. So I'm just going to stop capture so we don't keep capturing traffic right now by clicking the Stop Capturing Packets button in the top left here. And now we are no longer receiving captures. So let's take a look at this table and what each of these lines mean and the respective columns. So first and foremost, we have the captured packet number on the left-hand side here. We have a timestamp for when the packet was received. We have the source IP address. We have the destination IP address. We have the protocol of the packet that was received. We have its length. We have a info column here, which provides a bunch of different information. In this instance, this was ICMP, or a ping packet, which first provides a request for a response, and then we provide a reply to the requesting host. So in this instance, since we are spoofing the responses for 8.8.8.8, then we do provide the reply here to that particular IP address. This might look a little bit wonky, but that is what's happening here. So if we wanted to filter for these ICMP packets specifically, we can apply a filter in this apply a display filter text box here. So if I just type in the protocol ICMP, and we have this nice autocomplete menu. So if I put in just I, then we only see filters starting with I. But if we want to do ICMP and hit enter, then it will filter for only packets that are of the protocol ICMP. So this is what's referred to as a display filter. And we can also create display filters that contain various expressions. So say we do ip.proto. So this is an IP protocol. So therefore it's a part of ip.proto is equal to ICMP. It has to be all caps in this instance, and hit enter. Then we receive the same result as before. So let's do another example here, something that's an application layer protocol. So I'm just going to clear this and then hit enter. So that will clear the display filter that was just in place. So we're going to start capturing again by pressing the Start Capturing Packets button here. And then we can see that we're prompted to save our unsaved packets. So we're just going to click on continue without saving in this instance because we don't need to save this capture. And we start receiving packets right away again. And the next thing that we're going to do is visit an HTTP address in our Windows machine here. So I'm just going to open up Edge here, and then we're going to go to invokere.com. And then we get the default inetsim HTML response. Then if we go back to our Remnux machine, let's scroll down. And as you can see, there's a ton of noise here. So if we want to look at our HTTP request, we can type in a display filter of http.host is equal to invoke re.com. And then we can see the HTTP GET request here. So if we expand the protocol pane down here, so it's parsed the hypertext transfer protocol here, we can see that we're filtering on the host field here for invoke.re.com. So that's exactly what we set in our display filter there. Again, if we want to look at all the different HTTP fields that we can filter on, we can type in HTTP dot, and then we have all of these different fields that we can filter on. So in addition to that display filter that we can set, we can take a look at the analyze menu here, and this provides a series of display filter types. So first we have the display filters menu, and this provides a whole bunch of examples of different display filters that we can use. So for example, here, let's expand this. We can only display a specific MAC address. We can display a specific type of Ethernet packet, in this case, an ARP request. We can look at Ethernet packets with the broadcast address set in place. And then we can even negate specific protocols, so not ARP, for example, etc. So once we've defined a display filter in this menu, then it can be applied using this bookmark button on the left-hand side here. So for example, if we wanted to display TCP packets only, then we could select TCP only, TCP, and then it applies that bookmarked display filter there. So let's get rid of that and hit enter to display all the other packets. And the next type of display filters are macros. So if we click on analyze and the display filter macros, then this gives us more flexibility compared to those specific values and the ability to negate them or include them. So here we have the ability to use macros to specify ranges of values, for example. So in this case, we have the private IPv4 display macro, which has this variable $1 being the IP address is equal to 192.168.0.0, and then we have a network range that's specified with /16, and then we also have an OR statement, so we can have Boolean logic throughout these macro statements, and we can also specify alternative types of IP addresses. So for those of you who are not familiar, these are all reserved for private IPv4 address ranges, so that's why it's here. We can also do things like IPv6 using a similar format, etc. So as an example, let's create a new macro, and we'll just call this test. And we're just going to copy this macro here because for some reason when I was performing testing, I wasn't able to apply this macro actively, but if we created our own, then I could. So I'm just going to copy this text and paste this here. Okay, then I'm going to click OK. And then we have a specific macro pattern that needs to be provided in this display filter field in order to access that macro, which is in the format of $curly brace, the name of the macro, which ours is test. And then we'll do colon, and then this is the parameter that's being provided to the macro, which in that case was the IP address. So we'll do IP.adder. And then we'll close the curly brace, hit enter. And then as you can see, these are only for source and destination addresses that are within the private IP address range. Okay, so let's clear this, hit enter. So in addition to a single field being passed as a parameter to a macro, you can have multiple fields that are passed to a macro and then add additional Boolean logic, etc. So they can get quite complex. So let's continue to look at the type of display filters. So we can go to display filter expression in the analyze menu, and then we see a whole bunch of different field names that are accessible to us. So these are all the protocols that are essentially supported by Wireshark, which as you can see is extremely extensive. So what's super cool about this menu is if we filter on HTTP, then we can essentially construct an expression using the fields available to us. So say we do something like HTTP host again. So HTTP host, and then with the relation here we have a number of different things, but we can do something like contains and then invoke. Then we have the expression created for us. And then if we click OK, then that is provided in our display filter here. And then if I hit enter, then again, we can see our HTTP request here. So another extremely useful way that we can apply specific fields from certain protocols is dragging and dropping them from our parsed protocols here. So for example, if we expand this transmission control protocol or TCP, which is our transport layer protocol used in HTTP, then we have the destination port of 80. So if I drag and drop this into our display filter there, then it creates the expression for us. And again, we don't have to write that by hand. So a whole bunch of different ways that you can essentially create these display filters in order for you to look at specific parts of the protocols without having to write them by hand. There's a whole plethora of really useful functionality in Wireshark. So as you may have noticed, there's a bunch of different requests and responses from different protocols, and we can actually follow the particular stream of each protocol session. So for an HTTP request, for example, this MS download one, so this is trying to download Microsoft updates from an HTTP server for Microsoft. If we right click on this and then go to follow TCP stream, then what this is doing is it'll actually acquire all relevant TCP packets for that HTTP session, and it will create this display filter. So TCP stream equals 104. So this is a particular stream number for this TCP session. And then we have the relevant data from that stream in this Wireshark follow TCP stream window here. So this is the plain text HTTP data that was parsed from those TCP packets. And then we have the two sides of the HTTP conversation here. So we have the GET request that was performed, and then we have the HTTP 200 response that was provided to the requester, so our Windows machine in this instance. So if we wanted to look at different sides of the conversation exclusively, we can do that by using this entire conversation menu. The entire conversation is selected right now, which is why it's displayed. But if we wanted to change that, we could click on this and then click on the response side, which only shows that, the HTTP response, or we could do the request side, which only shows the HTTP request. So this type of view is super useful when you're looking at command and control functionality from a piece of malware, since you can view both sides of the conversation and what was requested and what was responded. Okay, so let's take a look at actual malware network traffic. So I'm just going to close this out, and I'm just going to restart our capture here. So I'm just going to click on restart current capture in Wireshark, continue without saving again. And then I'm going to clear this TCP stream display filter by deleting it and then hitting enter. And then we're going to go back to our Windows machine here, get out of this. And then I'm going to open our invoke RE lab samples and navigate to lab 12. And then we're going to change lab 12 example1.bin to lab.exe. And yes, we'll change it to .exe. So this is a good time to make sure that you have no network shares that are writable attached to the virtual machine, and double check that your virtual machine is on the host only network communicating with Remnux and not able to reach out to the internet. And that's because we're about to execute worm functionality from our sample that we analyzed statically and dynamically in previous labs. Okay, so I'm going to execute this by double clicking on it. Then we'll go back to our virtual machine and we start to see a whole bunch of TCP request packets that are then dropped. So before we look at those, let's take a look at this DNS request. So as we reverse engineered using static analysis and dynamic analysis already, we know that an MX DNS request is being made to the gmail.com DNS server. So that is what is being shown here is the DNS request for the MX record of gmail.com. So that's nicely summarized for us here. And then we can see the second request for the resolved MX record of mx1.gmail.com. So this was provided by inetsim. And then this is requesting the IP address for that mail server. And then we are providing the response for that from inetsim again. So if we expand the domain name system entry here with this tree menu, we can see that there is an answers part of the DNS protocol. And if we drop down answers, we can see that two mail servers were returned, mx1.gmail.com and mx2.gmail.com. And each of these records contain additional information such as the name, the type, which is the mail exchange record in this case, the class, the time to live, so that's all related to DNS, the data length, and the mail exchange record, etc. So as you can see, Wireshark provides amazing functionality by being able to parse all these protocols for us and then display them accordingly for us to easily read. So as I pointed out earlier, we saw a whole bunch of TCP requests that we're not going through. That's why these are shown in red, because these are reset TCP requests. So how TCP works is it will essentially perform a SYN request. So you can see that here. So the SYN request that's originating from our Windows machine and is destined for 147.26.228.174 on port 445 here. And as we reverse engineered in our previous labs with the static analysis that we performed, we know that this is destined for port 445 because this is attempting to perform self-propagation functionality from the worm to SMB, or the server message block protocol. So that's how we can see that this is being performed with the protocol TCP to port 445. It's making a SYN request. And since that port is not open on our Remnux machine, then our Remnux machine is sending back a reset ACK, which basically means that the port is closed from this machine. So essentially stating that the connection cannot be made to that port. And as you scroll through these requests, you can see those pseudo randomly generated IP addresses that it is attempting to make for different machines on the internet that it would then attempt to brute force using those series of credentials, or using the usernames that it was able to enumerate using SMB that we reverse engineered in the previous labs. So pretty cool seeing that it makes a huge amount of noise, and that these are all pseudo randomly generated IP addresses. So these will be different than what you're seeing on your screen. And this is a great indicator of compromise. So for example, if you saw a whole bunch of SMB traffic originating in your environment, then this would be a huge red flag that this machine was indeed infected with an SMB worm. So something to take into account, and you would include something like this in your malware triage report. Okay, so let's take a look at the SMTP C2 functionality from that worm sample that we analyzed in previous labs and see what it looks like in Wireshark. So I'm just going to stop capturing for a second while we set this up on the other machine. And then I'm going to go back to our Windows machine. So just to have a clean state to work with, and we're not generating that SMB traffic. Since this machine is infected with that worm already, I'm going to restore a snapshot. So I'm just going to do that now. And since we don't want to go through the steps of manually patching that check for the system username in that sample again, we can actually run that sample as system by using psexec. So I'm going to type in cmd.exe, right click, use run it as administrator in order to get an admin prompt. And what we're going to do is get a system prompt. So we're going to do psexec-i-s-cmd.exe. Okay. And then if I type in who am I here now, then we can see we're NT authority system. So this is the highest privileged user on a Windows system. And we just acquired that using this psexec command. So this is a tool by sysinternals, similar to procmon that we used earlier. And now that we're system, let's go to our desktop and go to our samples. And then I'm just going to move that sample to .exe. You can do this using the UI as well. Okay. So now we can see that lab 12 example 1.exe. Then I'm going to restart my Wireshark capture. Okay. And then I'm going to go back, and then I'm going to execute it from here within our system command prompt using // and then lab example 1.exe, and hit enter to execute our sample. And again, we have that spreader functionality that was executed, so it's executed that corrupt file, but that's okay. And if we go back here, we can see our SMTP protocol exchange that's taken place. So again, this is the command and control functionality that is being used through gmail.com in order to send information to the malware author that an infection has occurred. So we can see here in the info field, we can see that mail banner here, mail.inetsim.org, inetsim mail service ready. And we can right click and go to follow TCP stream. And then now we can see the SMTP protocol exchange in its entirety. Okay, and that will set you up for the SMTP C2 protocol exchange exercise.